Okay, let's knock this practice test out for Unit 6. So it says factor each expressing using a u substitution and write your answer in terms of x. So if we take a look at this one right here, you'll notice that we've got three terms, and the variable portion of that middle term has an exponent of 1 if we were to write it. And what we're checking for to see if this is in quadratic form and it's a good candidate for a substitution is we want to see if when we double that exponent, do we get this exponent right here? So if I double 1, I get 2, so this is perfect. So we're going to let u equal 2x minus 3, the stuff in parentheses. So this is going to be written as, we're going to replace the 2x minus 3 with a u, so this is going to be u squared. Replace this, that's going to be a u, and then that's a minus 2. So this looks better, but we're still going to need to factor this. So we're looking for two numbers that multiply to be negative 2 that combine to be positive 1. So I'm going to have a u here and a u here. This is the easy type of trinomial. So to multiply to be a negative 2 and combine to be a 1, I'm going to use a negative 2 and a positive 1. But if you think about that, they will multiply to be a negative, but they'll combine to be a positive. So we've got to make sure that that 2, the bigger one, is positive. So it's going to be a u plus 2 and a u minus 1. This is factored now, but we want to rewrite everything in terms of the original variable x. So now we're going to reverse the substitution. Wherever there's a u, we're going to put a 2x minus 3. So this is going to be 2x minus 3. I'll go ahead and put that in parentheses, plus 2. And this is going to be, we're going to replace the u, so 2x minus 3, put that in parentheses, and minus 1. So now I can go ahead and combine these. I don't need the parentheses on here anymore, so this would just be 2x minus 3 plus 2. So this is going to be 2x minus 1. And this one's going to be 2x minus 3 minus 1. So this one's going to be 2x minus 4. And that right there is the answer. So we'll go ahead and circle that one. And then we'll take a look at this. We've got, again, three terms, so it kind of fits that quadratic pattern. If I take that exponent and I double it, so if I times that by 2, do I get 2/3? I do. So great candidate for a u substitution to make this look simpler. So this is p to the 1/3. Remember, p to the 1/3, that would be the cube root if we were interested in using that. So this is going to be u to the 2nd plus 11u plus 28. And if I needed to, I could rewrite that one as p to the 1/3 squared. Remember that power to a power rule? We multiply those together. So it fits this pattern, and again, an easy trinomial. I'm looking for two numbers that multiply to be 28 that combine to be positive 11. So that's going to be plus 7 and plus 4. And I've got it factored. Now all I have to do is reverse the substitution. So this is going to be p to the 1/3 plus 7 and p to the 1/3 plus 4. Okay, and that's all there is to that one right there. Again, that's why we put the x in parentheses, because they may have used a different variable as we're going to on this one right here. So if we take a look at number 3, the thing we want to notice here is, like we were talking about up above, the square root of m is the same as m to the 1/2. And if I've got an m, that's to the first power. So if this is like m to the 1/2, I can double that and I get an m to the first. So this fits our pattern here. So wherever there's an m, a square root of m, we're going to put a u. So u is going to be the square root of m. So this is the square root of m squared minus 9 square root of m. Put that in parentheses, just kind of make that stand out. So again, wherever there's a square root of m, we're going to put a u. So this is going to be u squared minus 9u, and then plus 8. So again, an easy trinomial. So we're looking for two numbers that multiply to be positive 8 that combine to be negative 9. So that's going to be u minus 8 and u minus 1. Before we go any further, might be a good idea to just double check and make sure. Do they multiply to be a positive 8? They do. Do they combine to be a negative 9? They do. So I'm going to replace this. So this is going to be the square root of m minus 8. And this is going to be the square root of m minus 1. And that is what we'd circle for our answer. Okay, this one also fits the pattern. So if we double this one here, we're all set. Now, it's important to notice that what we're doing is we're just replacing the variable portion on this one. So just the x cubed is going to be what u is. So u is x cubed. And this is going to be 8u squared plus 2u minus 15. This is a more difficult trinomial, so we're going to multiply the two of these together. So 8 times 15, that's negative 120. and I'm going to highlight this. We're looking for some numbers that multiply to be negative 120 that combine to be positive 2. And we could take the time to throw that in the calculator, but we could also stop and think for just a second. The easiest way to make a 120 would be a 10 and a 12. So those would multiply to be 120, and we could combine them to make a 2, but again, one of them's got to be negative to make the answer negative when we multiply, and the middle one's got to be positive, so this has got to be a positive 12 and a negative 10. So double check right here so we make sure that we get this right. Do they multiply to be a negative 120? They do. Do they combine to be a positive 2? They do. So this is going to be 8u squared, and then minus 10u, and then plus 12u minus 15. So we'll go ahead and factor this. I can take out a 2 and a u. We're left with a 4u minus, let's see, if I take a 2 out of a 10, that's going to be a minus 5. And I can take a 3 out of both of those. I'm going to take a positive 3 out. We're left with a 4u minus 5. So this is, let's see, I take out the 4u minus 5, and I'm left with the 2u from that one, plus 3 from this one. And then all I have to do is just reverse the substitution. So I'm going to write this. This is going to be 4x cubed minus 5. And this one, when I replace the u with an x cubed, is going to be 2x cubed plus 3. And that is the answer. Okay. All right, let's take a look at the next couple. These are story problems. So this is quadratics in context. So we want to have all our methods available here. And make sure that we answer the question. And again, the important part here is, can you write down the equation? So we want to catch the key points here. 2 consecutive even integers, and we want their product to be 528. So the first one, we'll just call that x. And if it's an even integer, remember, we need to skip the odd one that's in between there. So we add 2 to that. And we need these two numbers to multiply to be 528. So I'm going to do x, the first one, times x plus 2. That's the second one. And we get 528. Now, you could solve this a bunch of different ways. But we first got to get this set equal to 0, because this is going to be x squared plus 2x. And I'm going to move this over. So this is going to be negative 528 equals 0. Okay. So we could use the quadratic formula. We could try and factor this if we want to. Let's check this and see if we could factor this really quickly. So I'm just going to pull up the calculator. And I'm going to type in, just to have our calculator help us out with this. We need them to multiply to be negative 528. So I'll go ahead and put in negative 528, and I'll divide that by x. And then I'm going to hit the table. So second table. And let's see, we're looking for numbers that are 2 units apart. Okay, and it's going to take us a little while to get there. Let's check and see. They're getting closer. 22 and 24. Let's see. Yeah, so that would work. If we use a positive 24 and a negative 22, we're going to be in good shape here. So this is going to factor to x plus 24 and x minus 22. Set that equal to 0. So the solution that we get from this one is x equals negative 24, and the solution that we get from this one is x equals positive 22. And again, those are both the x's, so those are the potential first values of this one. So I'm going to put first here and second here. So the first one, if the first one's negative 24, we add 2 to that, and we get negative 22. Okay? Or the other way we could do this is we could say the first one is 22, and then we add 2 to that, and we get 24. So negative 24 and negative 22, or 22 and 24. Either of those would work. We'd be fine with that. Okay. All right, let's take a look at the next one. On the next one, we've got to find two numbers whose sum is 300, then has the greatest maximum product. And then what is that maximum product? So we've got two numbers. We don't know what they are. I'm just going to use an x and a y. When we add those together, we get 300. So if I add those together, I'll get 300 right here. And we want them to have the maximum product. So when I multiply the two of them together, I want that to be a max. Well, we can't really solve either of these by themselves because they've got two variables. So what I'm going to do is I'm going to take this one and I'm going to solve for y. So I'm going to subtract x on both sides. So this is going to be 300 minus x is whatever y is. So if they add up to 300, you can think of y as being whatever's left of the 300 after I take away the x. So here's the product we're trying to maximize. This is going to be x, and then I've replaced this with 300 minus x, and we want to maximize that. So if we think of this as a function of x, if we multiply through here, this is going to be negative x squared. This is going to be plus 300x. So this is a parabola. It opens down. So it's going to look something like this. We want to know where the maximum is. So let's see. That's going to be, well, we could find this a couple of different ways. One way we could do it is we could use the formula that says the vertex is at negative b over 2a, comma, and then we just plug it into whatever the function is to figure out what the y coordinate is. And it actually wants, let's see, find the two numbers. So we have to find the actual two numbers, and we need to find the maximum product. So we need to find this coordinate right here. So we're going to take negative 300. Remember, it's the opposite of whatever b is. A on this one is a 1. So this is going to be 2 times negative 1. So we end up with, let's see, negative divided by a negative, positive 300 divided by 2 is 150. So that means the x coordinate of the vertex, horizontal coordinate here, is 150. And then we want to figure out what the other number is. Well, that's right here. So y would equal 300 minus 150. So that's also 150. Okay, so find the two numbers. So 150 and 150, those are the two numbers that produce the maximum product. And then we just have to multiply the two of those together. So I'm going to second quit here, and I'm going to do 150 times 150. Hit enter, 22,500. So 22,500, that's the maximum product. So here are the two numbers, and there's the max product. And I'll just write max next to this one. Now, just for the heck of it, if we were to come back and look at this right here, a couple of things we notice. First of all, let me make this a tad bigger and slide that over. Okay, so I'm going to slide that over here. Okay, if I were to plug in a 150 in there, so 150 parentheses 300 minus 150, this is like plugging it into the function. So that's the function right there. It's x times 300 minus x. You're going to get exactly the same answer. And then the other thing is, if you wanted to, right here, you'll notice that one of the zeros, one of the x-intercepts is 0, and from here you'll notice that it's 300. If you solve that for when it's 0, it's 300. So what this means is this crosses at 0 and 300, so you could quickly find that the x-coordinate of the vertex is at 150. Okay? All right, let's take a look at the next one. Whoops. On the next one, minimum product of two numbers whose difference is 8. So we want to be a little bit careful on this one. We've got two numbers and their difference is 8. So that means if I take one and I subtract the other, I end up with 8. And I want to minimize the product. So when I take those two and I multiply them together, I want to make that the minimum. Well, the problem here again is I've got two variables in both of these equations. So what I'm going to do so we don't scramble our brains, I could solve this one for x and then plug it in here, and then I've got a function in terms of y. That does tend to scramble our brains just a little bit, so I'm not going to do that. So here's what I'm going to do. I'm going to subtract x from both sides, and I'm going to have this. I'm going to have negative y equals 8 minus x, and then I'm going to divide by a negative 1. Okay, I'm going to make this zoom in just a little bit on this one. Okay. So this gives me y equals, this would be a positive x, and that would be a negative 8. Okay, so this right here is going to be the second one, but it's in terms of x. It's in terms of the first one. So here's my product. My product is x times x minus 8. And so now I've got a function of x, if you want to think of it that way. And again, we could have solved for this in terms of y. This one I'm going to solve for this by thinking about this as far as the zeros go. 0 here is 0, 0 here is 8, and this is x squared, so this is a parabola that opens down. So we've got, let's see, a 0 at 0, a 0 at 8. That's a parabola that goes like this. So that means the vertex would be at 4. And then if I want to find the other one, so that means x is equal to 4. So if I want to plug the other one, I plug it right in here. So I get y equals 4 minus 8. So y equals -4. So here are the two numbers. The first one is 4. The second one is -4. It doesn't ask for the minimum product. Or wait, it does. Oh, it does. It asks for the minimum product. So we multiply the two of those together. And I'm just going to write min. If you multiply those together, you end up with -16. So there's the answers, the two numbers that have their minimum. The minimum would be -19. And if you were to plug them in here and you were to find where that vertex is, that vertex would occur at 4, -16. Okay. All right. Next one, we've got a farmer. He's fencing in an enclosed rectangular corral, and he's using his barn as one side of the corral. And it says what dimensions will, let's see, create the maximum area for the corral. So he's using a corral on this one. So on this, let's draw a picture. We've got a corral that looks like this. So it would be best, because if I choose X right here, I get another X over there, and then this would be Y. And what I know about these is if I add these together, I'm going to use up the 600 feet of fence. So this would be 2 X's plus a Y equals 600. And what we want to do is we want to maximize the area. And the area of that rectangle is going to be X times Y. So we're going to do the same thing we did up above. We're going to do Y equals 600 minus 2X. And then I'm going to take this and I'm going to plug it in right there. So this is going to be X times 600 minus 2X. And that's our function of X. And we know that this has a maximum, because if you take a look at this, I'm going to leave it in this form, but I'm also going to write this. F of X equals, this would be -2X squared. And then this would be plus 600X. Looks all right. Okay, so then we've got a bunch of tools for doing this, and it says what dimensions will create the maximum area. So all we need are the dimensions of this. We need X, and then we're going to use X to find out what Y is. So let's see. You got your choice here. It's a parabola that opens down. You could use the -b over 2a if you wanted to use this one. We could also say that this has a 0 at 0, and if you solve for when that's equal to 0, this would be -2x. Move the 600 over, that'd be -600. Divide by, let my computer catch up here, divide by -2, so you get 300 from this one. No surprise there. So we've got a parabola that opens down, goes like this, crosses at 0 and 300. So this would be at 150. Okay. So oddly enough, on this particular one, we get another answer of 150 like we did up above. But here's the catch on this one, I think. This is the X coordinate of the vertex. It's whatever variable we were solving for here. So that means X is 150. So let me draw this. This is 150, which means this is 150, which means we've used 300 of the 600 feet. So that means this is going to be 300 here. We could also plug X equals 150 into this equation. 600 minus 2 times 150 is going to be our 300. So it asks for the dimensions. It doesn't ask for the maximum area. So the dimensions are going to be 150 feet by 300 feet. Okay. All right. Let's go ahead and take a look at the other side. Okay. It says a ball is thrown directly upward from an initial height of 100 meters. The initial velocity is 50 meters per second. Okay. How long will it take the ball to reach its maximum height? Okay. So for this, we need to remember the formulas. So h of t, this is those projectile motion equations that we were talking about. In the metric system, this is going to be -4.9 t squared plus v naught t plus h naught. So v naught is the initial velocity. And again, in this reference system, down, gravity's pulling down, so down is negative and up is positive. So we'll keep that in mind when we do the velocity here and write the equation. And then h naught is the initial height. So here's the initial height, 100 meters, so there's h naught. And this is v naught because that's where it starts. And notice that it's positive because it said it was directly upward. If they had said downward, then it would be a negative for that one. So here's the equation that we're going to write down on this. We're going to write down for A, and all the other ones on this. This is going to be h of t is equal to negative 4.9 t squared plus 50t plus 100, okay? And it says, when will this reach its maximum height? Well, if we launch it from 100 feet and it goes up and then comes down, it's going to hit this right here. So it's asking for how long will it take it, how many seconds go by before it reaches its maximum height. So what we're asking for is the x-coordinate of the vertex, horizontal coordinate of the vertex. It's actually the t-coordinate of the vertex, but either way, we're using this formula right here. So negative b over 2a, and then we're going to take this and we're going to plug it into the function if we need the maximum height. So I'm just going to write h, and then we're going to plug this in here. So this is going to be negative b, so that's negative 50, divided by 2 times negative 4.9. And for that, I'm definitely going to reach for the calculator. So I'm going to clear this off, and let's see what we end up with. So I've got a negative 50 on the top, divided by, and I'm going to put this in parentheses so we make sure we get this. If you don't put it in parentheses, you can end up getting a wrong answer. You're welcome to try that. So 2 times negative 4.9, close the parentheses. What this is going to tell the calculator to do is it's going to multiply the two of those together, then it's going to carry out the division. So if we hit enter, I get 5.102, so that's going to be 5.1, okay? And that's a time, so that's in seconds, okay? So it's going to reach its maximum in 5.1 seconds. Just for the heck of it, I'm going to recall this and watch what happens if I delete the parentheses. Delete that, hit enter. I get 122.5. So you know that's got to be wrong. It's not going to be it's not going to take that long to get it to its maximum. What it does is it divides the two of those, then multiplies by negative 4.9. So make sure you're careful in how you put them in the calculator. You could also put it in using the fraction menu if you wanted. So we've got 5.1 seconds on that one. Then it says, what is the maximum height? So for part B, we're actually going to plug this in here. So we're going to figure out what is, let me put a B right here. We're going to figure out what is h of 5.10, okay? So that's going to be negative 4.9, 5.10, whoops, we'll just put 5.1 squared, plus 50 times 5.1, and then we're going to add the initial 100. Okay, so I'll just type this into the calculator and see what we end up with. So this is going to be, let's see, negative 4.9, and I'll do parentheses 5.1. We're going to square that, and then this is going to be plus 50, parentheses 5.1, and then we're going to add 100, hit enter, and I get 22. So yeah, 227.55. So h of 5.10 is 227.55. And again, this is going up, and we're figuring out the y-coordinate of the vertex. So the x-coordinate, the t-axis here, is in seconds. This is the height axis, and that's in meters. So I'm just going to put a big fat meter right there, and there's the answer to that one. And then the next one says, when will it hit the ground? So we want to know, when does this actually crash into the ground? So let's see what that is. If it crashes into the ground, the height is 0. So we're basically saying, hey, will you solve this for us? We want to know when this equation equals 0. So I'm going to do 0 equals negative 4.9 t squared plus 50t plus 100. And then I'm going to zoom in on this one because this is going to take a little bit of extra effort here. This is going to be t equals, I'm going to throw this into the quadratic formula. This is going to be negative 50 plus or minus a big square root. This is going to be 50 squared, which I know is 2,500, then minus 4 times a times c. So this is going to be a is negative 4.9, and then c is 100, and then that's all over 2 times a, so that's 2 times negative 4.9. Okay. Now, part of this, I would like to figure this out because this shouldn't be too horrible. This is going to be 2,500 plus something, so it should get bigger. So I'm going to type in 2,500 or 2,500, and then minus 4, and then parentheses negative 4.9. times 100. Let's see what we end up with here. Okay, so yeah, we get 4460. So let me just double check here. Looks good. Looks good. Um, let's see. I'm gonna just type this in from scratch and just do 50 squared just to double check I'm making sure I get this right. 50 squared minus 4 times a, which is negative 4.9 times c, which is 100. Hit enter. Yep, we're in good shape there. So, and the bottom is going to be negative 9.8. So this is negative 50 plus or minus. This is the square root of 4460. And then that's over negative 9.8. And I'm going to throw this into the calculator. And if we stop and think about this, yeah, I think it's going to have to be the one that with the minus. So I'm going to grab the calculator and I'll just put both of these in. So I'm going to do alpha y equals, just to make this look nice, negative 50. And then I'm going to do plus a square root of 4460. Then I'm going to hop down on the bottom, and that's negative 9.8. Hop over here, looks like the positive example of that one. So I hit enter and I get a negative number on this one. So there's no way that can be it. So I'm just going to recall this, come back over here, hop through here. That takes a little bit. I'm going to change that to a minus, hit enter, and I get 11.91. Okay. So 11.916. So we'll call that 11.92, and that's going to be in seconds. Okay. All right. Let's check out this next one. Length of a rectangle is 4 centimeters less than the width. So I'm going to draw a rectangle on this one, and we're going to go full screen here. So the length of a rectangle is 4 less than the width. Okay, so the width I'm going to put here, not that it matters. And the other one is 4 less than that. So this is going to be x minus 4. And then the area, so if we multiply the two of those together, we get 252. So x times x minus 4 equals 252. So we're going to take this, we're going to distribute through, and we're going to get x squared minus 4x. If I move that over to the other side, because we're going to take advantage of the zero property of multiplication, I can then either solve this using factoring, quadratic formula, if I wanted to complete the square or something like that. We could check really quick. Let's see if we can factor this. I'm going to make that a little bit smaller, clear this off. I'm going to go to y equals, and I'm just going to type in negative 252. Okay, and I'm going to hit the table, and we're looking for numbers that are 4 units apart. Let's come down here and see if we can find some. They're getting closer together, so that's good. Oops, let me see here. Did we pass something up? Oh, we got to go this way. There we go. Yeah, I was already at a different part in the table. Okay, so there's some that would work. Okay, 14 and 18, those are 4 units apart if we think of those. And so I need them to multiply to be negative 252 and combine to be a negative 4. So I need the bigger one to be negative. So that's my pair right there. So this is going to be x plus 14 and x minus 18 equals 0. Let's just double check. Do they multiply to be negative 252? They do. Do they combine to be a negative 4x? They do. So the answer that comes from here is x equals 14. And the answer that comes from here is x equals, this is a negative 14. Make that look better. Okay, so this is a negative 14. And this one is a positive 18. And since we know we're dealing with a real world problem and we're talking about the dimensions of a rectangle, we can't have the negative one. So it's got to be the one that's 18. Okay, so this is going to be 18 for this side, and then that one's 4 smaller than that, so that's going to be 14. So what are the dimensions? 18 by 14, and that would be in centimeters. Okay, all right, let's come down here, take a look at a few more of these. Okay, now we get to the ones where we're solving quadratic inequalities and things like that. So on this one, we first want to make it a quadratic. So we're going to do x squared minus 4x. I'm going to move the 3 over, so that's going to be adding 3. So we're going to compare it to 0. So here's the deal. We want to see when this graph, when this shape is less than or equal to 0. So we want to see when it's negative or 0. So what that means is negative would be below the x-axis. So below x-axis, and equal to would be on. So below or on the x-axis. So if I were to graph this, which would be really easy, it's a parabola that opens up. And if I know what the zeros are, then I'm in good shape. So I'm going to factor this. I need two numbers that multiply to be 3 that combine to be -4. So that would be a -3 and a -1. The root that I get from this is 3. The root that I get from this is 1. So I've got a parabola that opens up, that crosses at 3 and crosses at 1. Okay, so it looks like this. And we want to know when this is below or on the x-axis. So if that's 1 and that's 3, the answer on this one is from here to here. So this is going to be 1 to 3. Put square brackets around that because it can actually be on the x-axis. Okay, so on this next one, this is a parabola that opens up. So we got that part taken care of, similar in shape over here. But we want to factor this. So we need two numbers that multiply to be 25 that combine to be -10. This is one of those perfect trinomial squares. So this is going to be x minus 5 quantity squared, which I'm just going to write out this way. And once I've got that factored, let's just double check. Do they multiply to be positive 25? Yep. Do they combine to be -10? Yep, we're in good shape there. So that means the 0 that we get from each of these is just 5. So this is one of those double solutions or double roots. So here's what this does. This hits the x-axis right here and it opens up. So that's what we've got. And let's come back here and take a look at this. This is asking, when is this graph greater than or equal to 0? Greater than would be positive, positive or equal to 0. When it's positive, it's above the x-axis. When it's equal to, it's on the x-axis. So above or on. So when is this graph above or on the x-axis? Well, that's everywhere, the whole thing. So the values of x that would do that are -infinity to infinity. Okay? All right, now the next two, these are not quadratics, but these are rational functions. So let's take a quick look at this. We want to know when this graph is above the x-axis because it's greater than. We don't want to graph this, and we don't want to use test points or anything. So what we do is we use that clever little trick. When we're solving an inequality, we solve it just like we do an equation, except when we multiply or divide by a negative. So what we're going to do is we're going to clear the denominators by multiplying by x minus 3 quantity squared, because if I multiply by that squared quantity, I know I'm multiplying by a positive. That doesn't change this side at all because it's just a 0. It doesn't change the inequality because we're multiplying by a positive, and I can cancel this factor with that factor. So this is just x minus 3 times -x, and I'm going to put that in parentheses. Now, we should kind of talk about this. It's not a big deal on this one because it doesn't include any of the zeros, but there is one number that we can't plug into this. Because we're dividing by x minus 3, there's no way on this problem that x could be equal to 3. So we're gonna throw that out even if we get that as part of the answer. So if I multiply through here, this is going to be -x squared plus 3x. So this looks like -x squared, so it opens down, and the x-intercept we get from this one is 3, and the x-intercept that we get from this one is 0. So here's what we're looking at. It crosses at 0 and crosses at 3, and it goes like this. So that's 0, that's 3, and we want to know when is this graph above the x-axis. Well, above the x-axis goes from here to here, so from 0 to 3, and not at 0 and not at 3 because right there it would be on the x-axis. Okay, so we don't include those, so we're going to use round brackets on this. So there's the answer on that one. And then we'll take a look at the next one. Notice that we're using the same denominator, so I'm going to throw that one out again. So say, hey, we can't have a 3 in the answers here, but let's see if it works out that way. We're going to multiply by x minus 3 quantity squared, x minus 3 quantity squared. Those are going to cancel. That's just a 0. So this is going to be x minus 3, 2x plus 1. If I multiply the two of those together, I get the overall shape. That's the most dominant term here, so 2x squared. That's going to be a parabola that opens up. So the x-intercept from this one is 3. The x-intercept from this one is -1/2. So parabola that opens up. and it crosses at -1/2 and +3. And it goes like this. And what we want to know is where is this? Let's see, less than 0. That would be negative. So that's below the x-axis. So it's below the x-axis from that -1/2 all the way to 3. And because it's strictly below, we're going to use round brackets so we don't need to worry about throwing out any of those numbers. We kind of already throw them out. Okay? All right, we got a couple more to do here. Let's see how this goes. Oops, cancel that. Make that full screen. And we'll come down here. It says solve for the indicated variable. So on this one, here's what we need to do. We need to get the r all by itself. And you'll notice the r is right here. As far as we're concerned, that's the only variable in this particular problem. So I want to get that r by itself. So the first thing I'm going to do is I'm going to get rid of the denominator. So I'm going to multiply both sides by 360. So this is going to be 360a. And I don't really recognize this formula from very many things. So we're just going to assume that this has something to do with a circle or whatever, okay? And then this is going to be pi r squared and an s. I want to continue getting the r by itself, so I need to get rid of the pi and the s. So we're going to divide this side by pi s and this side by pi s. So those are going to cancel. And I end up with just an r squared over on this side, and I've got 360a over pi s. And then I need to get rid of the square, so we get rid of a square by taking a square root. So we're going to take a square root, and we're going to get r equals, remember, when we put a square root in a problem, we have to put a plus or minus on here. So this is square root of 360a over pi s. Okay. Now, we could kind of make an argument for, hey, I'm just going to leave it like this. The other thing we could do is we could say, hey, I think this has something to do with a radius, and radiuses have to be positive, so we might want to make an argument that it should be just a plus instead of a plus or minus. We could also do a little bit of simplification on this one. This is 36 times 10, and that's a pair of 6s. So you could write this one as just 6 and then square root 10a over pi s. But it's probably not worth it to do that. So I would probably take either this or this. Don't really care which one. You could make an argument for both of those. The important thing is, do you know how to get that by itself? If we're going to simplify this, we probably want to say, well, I got to simplify and can't have a square or a fraction underneath a radical or something. Okay. Let's take a look at this next one. This is solve for z. So z is up here. So the first thing I'm going to do is I'm going to get rid of the 2. So we're going to multiply both sides by 2. So this is 2p equals, this is a z squared minus 6z. And there's no way to get that z by itself on one side, because if I try and move this z over there, then I've got that one over there. I could try dividing by a z, but that's going to put z in the denominator, a whole bunch of things. So what we're going to do here is we're just going to recognize, hey, this is a quadratic. So let's make it look like a quadratic. Let's see what these three terms are. This is a z squared, this is a minus 6z, and then this is a minus 2p. Now, wouldn't want to factor that. That's a mess, and really wouldn't want to do anything other than we're going to throw this into the quadratic formula. So let's make sure we're clear here. A on this is a 1, because that's what we've got in front there. That's a 1. B on this is a -6, because that's the coefficient in front of the regular linear term, the z term. And then C on this one is -2p. It's that entire constant right there. And then we're going to plug this into the quadratic formula. So we should have that memorized. So this is going to be z equals, it's going to be -b, opposite of b. So that's going to be a 6, plus or minus, and then we're going to have b squared. So that's going to be 36 minus 4 times a times c. So a is a 1, c is a -2p, and then on the bottom we've got a 2 times 1. Okay, so that means z is going to be equal to, let's see what we get here, 6 plus or minus, this is 36, this is going to be a plus, let's see, that's plus 8p all over 2. And then we could probably make some arguments for should we do something with this. We could probably take out, if you'll notice, we can take out a 4. I'd probably be fine with you leaving it this way. I'm just going to put a dotted circle around this one, say we'd be okay with that. If we wanted to and get a little bit tricky, you can't just take the square root of each of those pieces. Remember, square roots do not play well with addition and subtraction. So we could do this, and I'm going to change colors for this. This would be 6 plus or minus. I can take a 4 out of both of those. So that would be a 9 plus 2p, and that would be all over 2. And then I can take out, if you'll notice, I can take out a pair of 2's. So this would be 6 plus or minus 2 radical 9 minus 2p all over 2. And then if I wanted to reduce everything by a factor of 2, this is going to give me a 3 plus or minus, because let's see, that's going to be 6 over 2, and this is going to be plus or minus 2 over 2. So this is just going to be 3 plus or minus 9 minus 2p, okay? And we could write that down as the answer, okay? But again, you could make arguments for how far do you want to go with this, and how much work is that actually worth. Let's go ahead and take a look at this next one. We want to solve it for x. So we want to first get the term with the x by itself. So I'm going to come over here and I'm going to subtract y minus 3 quantity squared. Y minus 3, computer's catching up here. Subtract y minus 3 quantity squared. Those are going to cancel each other out. So I'm going to end up with an x minus 5 quantity squared equals 4 minus, let's see, y minus 3 quantity squared. And then I need to get rid of the square on here, so I'm going to take the square root. So I get x minus 5 equals, remember we have to put a plus or minus on here because we're putting that in there. Okay, and let's see, this is 4 minus y minus 3 quantity squared. And then the last thing we need to do to get the y by itself is just add 5. So if I add 5 to both sides, here's what we end up with. We end up with x equals 5 plus or minus, and then we're going to have this big square root, 4 minus y minus 3 quantity squared. And all of that stuff is underneath the square root. Okay, so that's what we get there. And then here's the last one. This has taken a while, but we're almost there. First thing we notice is it's in the denominator. Certainly don't want to deal with it down there. So I'm going to get that up out of the denominator by multiplying by the r squared. Zoom in on this just a little bit so my handwriting hopefully will look better. So this is going to be fr squared. This is going to be g, and then m1, m2. Now, if we know what this is, great. I mean, we might suspect that this has something to do with the radius, but we don't know for sure. So we're going to, when we're done with this, we'll probably leave the plus or minus. We're going to continue getting the r by itself, so we're going to divide everything by f. Those are going to cancel, and we end up with, let's see, r squared equals capital G, and then it's going to be m1, m2 all over f. Get rid of the square by taking the square root of both sides. So here's what we get. And again, without more information, we're going to go ahead and leave the plus or minus. So this is going to be the square root of G, M1, M2, and then F. I do recognize this formula. It might be interesting for you to look it up. It's actually the gravitational force between two masses, and it depends on whatever the radius is, or it has something to do with that. Okay, so there you go. Good luck on the test.